So welcome back. In this session, we are going to do an example on how to show that commutative property works for convolution. So let's see the equation. So the equation is, show that convolution of f and g is the same as g convoluted with f, where the function f is 2t and the function g is 3t. So let's show this. So from the word go, let's define convolution of f and g. So solution, case 1. So case 1 is to show f star g. So f star g by definition is given by the integral from 0 to t f of t minus v multiplied by g of v, then dv. So now f of t equals to 2t implies f of t minus v will be given by 2 times t minus v, which is 2t minus 2v. And then g of t given by t cubed implies that g of v is given by v power 3. So which tells us that now convolution of f and g would be given by the integral from 0 to t, and then replacing this we get 2t minus 2v, and then multiplied by v cubed dv, which is the integral from 0 to t, and then 2t v power 3 minus 2 v power 4, and then integration is done with respect to v. Now, integrating this will get, actually can factor out 2, and then this will give us t v power 4 over 4 minus, this will be v power 5 over 5, and then v from 0 to v equals to t. So, which is the same thing as say 2 into, so when you replace t for v here, we'll get t times v power 4, which is t power 5 over 4 minus t power 5 over 5, and then lower limit will be 0, so minus 0 just means the same thing. So it'll be 2 times, now we have a quarter minus a fifth, t power 5. So that will give us 1 over 20 t power 5. Now multiplying this one by 2 gives us 1 over 10 t power 5. So that is case 1, f convoluted with g. Now case 2, the other way around, we define g convoluted with f by definition will be given by integral from 0 to t, and then g of t minus v times f of v, then dv. Now we have been given that, so given g of t is t power 3 implies g of t minus v will be t minus v raised power 3. When you work out, you get t power 3 minus 3t squared v, and then plus 3tv squared, and then minus v power 3. And then f of t in the question is given by 2t, so which implies that f of v will be given by 2v. So therefore, this implies that g convoluted with f will be the integral from 0 to t. Now g of t minus v, we have t power 3 minus 3t squared v plus 3t v squared minus v power 3. You multiply this one by f of v, which is 2v, then dv. Now, because this is a product, we can always factor out these two, because are constant, so it will be the same as 2 integral from 0 to t. So v multiplied by every term here will have v t power 3 minus 3t squared v squared plus 3t v power 3 minus v power 4. And then we carry out integration with respect to v. Now, this will give us twice. This with respect to v will get v squared t cubed over 2 minus, this will give us now v power 3. So dividing by 3, then we'll have just t squared v power 3 plus, this would be 3t v power 4 over 4 minus v power 5 over 5 divided by, okay, v of v power 5 over 5, then v from 0 to v equals to t. So this will be twice. Now replacing the upper limit, remember lower limit will be 0 because of the term has b. So this will be t squared times t power 3 t power 5 over 2 minus t squared times t power 3 will be t power 5 plus t times t power 4 is t power 5, so 3t power 5 over 4 minus t power 5 over 5. So lower limit is 0, so minus 0 remains the same thing. So it's like I have 1 over 2 minus 1 plus 3 over 4, and then minus 1 over 5, then t power 5. So this will give me 2 times, all this bracket will give me 1 over 20 t power 5. And when you work out, you get 1 over 10 t power 5, which is the same result that you obtained in case 1. Remember, this was the answer for case 1, t 1 over 10 t power 5. And so this is also giving us 1 over 10 t power 5. So clearly, f convoluted with g is the same as g convoluted with f. And in this case, the answer is 1 over 10 t power 5. So that's how we show that commutative property for convolution works. Actually, it's in general and will be specific to this particular question. Thank you.